Do we need the EPS-box with a Solax X3 Hybrid inverter to have emergency power? Do I recommend it, or it is definitely possible without it? What is the difference between an installation with and without the Solax EPS-box? With this topic in today's episode, a very warm welcome to my English YouTube channel. I have decided to publish the most important videos from my German YouTube channel in English, and I hope for your support by sharing my videos, liking them and writing your opinion in the comment section below. As you know, I am from Austria. And my German channel is very successful, but English is not my native language, so I may not present it as emotionally as I do it in German, but my goal is still to provide you with value. I have realized that my goal is not to set up simple photovoltaic systems. I have done that thousands of times in my life. My special focus is to helping people all over the world to use green energy that is available in unlimited amounts. Green energy should be available to everyone, and I am working on making this happen in big projects all over the world. We face two significant issues on this planet: an energy crisis and a flawed monetary system. My mission is to contribute to solving these problems. Only few people understand how deeply interconnected these two issues are. At the most fundamental level, everything on this planet is built on energy and time. This is where my theories comes into play. It is possible to make energy available to everyone without any cost to the population. This is feasible because there is more energy that we can consume, and this surplus energy can generate purchasing power. Anyone who learns to harness this energy can benefit from it. Energy can be stored as purchasing power and transferred into the future. I will explain more about this in my upcoming episodes. Also, I will share important information about the Solax X3 Hybrid inverters. I will talk about the various connection options, the most important settings, and explain how to become independent from public providers. I will also talk about how to expand existing systems and tell you everything about the different surplus control options. However, I won't cover everything in today's episode. As I mentioned before, today's episode will focus on the Solax EPS-box, whether it's absolutely necessary, and the characteristics of the installation with and without it. If you're interested in this topic, stick around until the end, take a few seconds during the intro to scroll down, press the like button, subscribe to the channel, activate the little bell. As you know, I am Alex, and now I would say, let's do this. I keep hearing it, but from people who have been poorly advised, and also from some solar installers, that to have emergency power, we first need a changeover or EPS-box, require a smart meter, or even worse, that it will not work without the matebox advanced. That's not true. Firstly, installing the EPS-box is definitely not wrong. In many cases, I do recommend it, but it is not essential for having emergency power. The EPS-box defines how the system works in grid parallel mode. When the inverter is in EPS mode, meaning it's running in off-grid mode, where the public grid is physically disconnected, The operation of the inverter is the same with and without the EPS box. In this case, the EPS box just sits between the inverter and the consumers. The main difference is in grid parallel mode. And what happens at the moment when the power goes out or comes back? In grid parallel mode, the EPS box defines the path the electricity takes when it flows from the grid to our consumers. And it defines the point where the electricity from the public grid meets the electricity that has been converted from DC to AC by the inverter. This meeting point where the electricity from the public grid and the inverter met is outside the inverter, typically under the right conductor of the EPS box. For example, in our household, if we are cooking, we might need 5 kilowatt. However, we are only producing 3 kilowatt and the battery is empty, so we need an additional 2 kilowatt from the public grid. If we have installed the EPS box, it looks like this. 3 kilowatt flow from the grid output to the inverter, and the missing 2 kilowatt come from the public grid. These 2 kilowatt meet the synchronized 3 kilowatt coming from the inverter under the right conductor in the EPS box. The total 5 kilowatt then flow through the right conductor, entering from below and exciting from above, and continue together to our consumers. As explained, the electricity from the public grid bypasses the inverter it meets, as mentioned, outside the inverter with the electricity from the inverter. When the right conductor detects voltages at its lower end, it allows current to pass through. This is known as pulling in. If the grid fails, causing a power outage, the inverter detects it too. The inverter is programmed to shut down its grid output if no voltage is present. This results in no voltage at the lower end of the right conductor either. With nothing coming from the public grid, the inverter grid's connection is dead and the right conductor shuts off simultaneously. The operation of the inverter's grid connection is always the same. As soon as there is no voltage from the public grid, it disconnects the grid connection. As a result, the right conductor shuts off. With the inverter default settings, voltage is only present at the EPS output, which is connected to the lower end on the left conductor, when there is no voltage at the grid connection. Therefore, just a moment after the right conductor shuts off, the left conductor pulls in. And because it now receives voltage from the EPS output of the inverter. Once the left conductor is engaged, electricity flows directly from the EPS output through the left conductor to our consumers. As an additional safety measure, to ensure that this is absolutely impossible from the power from the EPS output to flow back into the public grid, the two conductors interlock each other both electrically and mechanically. Each conductor has a mechanical switch operated by a mechanism on the conductor, and through this switch flows the neutral wire connected to the coil of the opposite conductor. This means it is both electrically and mechanically impossible for electricity from EPS output to enter the public grid, provided the EPS box is correctly installed. A very common error occurs with the neutral wire. For all electricians out there, the neutral wire of the EPS output must never be connected to the neutral wire of the public grid. If the EPS connector engages and then quickly disengages and the inverter restarts, this is the reason. The return current must flow back to the power source, which is in a power outage, the Solax X3 Hybrid inverter. Installing in this way is always correct and sensible, but it also works without an EPS box. And when installing without an EPS box, the electricity from the public grid doesn't bypasses the inverter, but instead flows through the inverter to the consumers. We also want to supply with emergency power. It enters the inverter through the grid connection, merges with the electricity from the PV system inside the inverter and then flows out together from the EPS output. However, for the EPS output to provide power even when there is voltage from the public grid, we need to deactivate the external ATS function in the advanced settings, which is enabled by default. We generally have the options to connect consumers on both the EPS side and the grid side, but only consumers connected on the EPS side will be supplied during a power outage, which makes sense because the grid side will be without power. So we are basically passing the grid power through the inverter, and this works the same way, with the added benefit that we don't have to worry about the switchover time of the relays. Switching the relays can take up to 2 seconds, but disconnecting from the grid without the EPS box is seamless because the power comes from the EPS output anyway. This means nothing needs to switch, we only need to disconnect from the public grid. So, why do we need the EPS box if it works the same way or even better without interruptions? The thing is, we can pass through round about 1.5 times the rated AC output power of the inverter as grid power. For a 15 kilowatt inverter, that's a bit over 20 kilowatt. So if any point you need more than 20 kilowatt for the consumers connected on the EPS side, it will not work. As soon as the load exceeds the maximum pass-through capacity, the inverter shuts down and restarts, and this will keep happening until the load's reduced. That's the downside. Also consider the following. Imagine you have a short circuit because of some faulty electrical device. Normally, the fuse would flow. Why does the fuse flow? Because due to Ohm's law, which states that the resistance is usually zero during a short circuit, an infinite amount of current would flow. To prevent infinite current flow, which would cause the wires to burn up quickly, we have fuses that blow when more current flows than they are rated for. If you have some electrical devices with fuses rated higher than the inverter can handle, then logically the fuse will not blow. But the resistance during a short circuit is still zero. So what happens? The inverter is short circuit proofed, meaning it will go in fault mode. But the problem with this is that if the fuse doesn't blow, you don't know which circuit caused the short circuit. So my fazit is, if it's important for you to be able to charge an electric vehicle during a power outage, or if you want to connect high power consumers like a sauna or other very strong devices to the EPS site, then I recommend you the EPS box. If you have a hybrid inverter with less than 10 kilowatt output, I recommend it anyway. I hope the video was interesting for everyone who is deciding whether to install with or without the EPS box. I also hope It was understandable for everyone. Please write me your opinion about the video in the comment section below. Share the video with your friends. If you like it, give me a like. That would support me and my work. And we will see each other again in the next episode.